Okay, so welcome back, and today I'm going to do another repair again on a laptop. Right, so I got it here from a tech as is without the back cover, and he said that it's not turning on. Right, so it's a HP, and I'm going to see if I can fix it. Alright, so I'm going to plug in the power. Right. It's on this side. Alright, so I'm plugging in the power. I get white light. As you can see, I got the white light, and I'm taking, well, I just saw about 10 or 11 milliamp there, but it's gone, but I'm still having the white light. Alright, so I'm pressing the switch. Alright, so I take 30 milliamp, and there's no white light here as well. There's no white light, and then it goes away. I'm pressing the switch again. Alright, I get 30 milliamp. There's the white light here is not lit. The white light here, alright, the power indicator is not lit, or the power on indicator is not lit. So, and then it goes back to 1 or 15 milliamp, and it goes back to 0 standby. So it's definitely not turning on. Alright, so I'm going to remove the battery. Alright, let's see. So, alright, so I moved the battery, so I'm going to try again. Alright, plugging in the power. Pressing the switch. Goes to 30 milliamp. No power LED, no power on indicator is not there any as well. Right, and then it goes back to 0. So as you can see on the DC power supply there, see, it goes back, shuts down itself. Alright, so I'm going to do some basic checking before I disassemble the machine, or as well the visual inspection. So I'm checking on the embedded controller area here. Alright, this is the embedded controller. All is well there. Alright, here is the RAM supply section. Alright, I've seen it burn any liquid intake there. Alright, that's the RAM power supply. Alright, that's the LAN chip there. Alright, no, all is well there. Alright, this is the the SSD drive. This is a 5. This is the charging coil. This is the charging coil. All is well there. Alright, this is the standby section here. 3V and 5V coils. Seems pretty fine. Alright, so I'm going to do I'm going to take out the board. To see the other side of the board. Oops, that one is a bit rough. These fans have a tendency to stop work for no reason. Alright, so the board is out. Alright, so another visual inspection on this side. Alright, so this is the power switch and the lid switch X section. All is well there. Alright, this is the audio IC. Alright, as you can see, the board is LAK203P, and these are the MOSFETs for the adapter. And I'm not seeing anything obvious on this side. Under here, I've never seen any liquid spill under this side, so I don't even need to remove it. Alright, so all is well, and there's not much components on this side of the board, as you can see. There's not much components on this side of the board. Alright, so I'm going to check for some resistances now on all power supplies on the coils. Alright, so off that one. Alright, so I'm going to start with the RAM supply. Alright, I get 97 there. Alright, bias chip 340. Let me remove the SSD drive. Alright, so I'm checking 5 volts, 396, 3.3 volts, 340. Alright, so I need to see 1.8 volts section as well. This is a common issue with these HPs. I've seen it before, where the 1.8 volts is not generated. VCC PRIM 1.8 is not generated to produce the CPU power or to complete the complete standby power supplies. And as you can see, this is a 12th generation CPU. Alright, so 1.8 volts should be here, and I get 300 and hold on, 1.8 volts is 304, and this is the charging coil 507. Alright, so I'm going to plug in the power. Oh, let me check the secondary 3 and secondary 5 volt section. Secondary 3, $482, and the other secondary $426. Alright, so there should be another. There should be an, here is it. That's 127, and the other 124, 122, 121. Alright, 121. So there's no obvious short. Alright, I'm gonna plug in I'm gonna get the power adapter, DC jack. Alright, so I have the DC jack. Oh, I didn't check this coil. This should be VCC in AUX, which is 1.8 volts, and I get 198. Alright, so I'm plugging in the DC jack. The power switch is on the board already. Alright, so I'm going to press the switch. Oh, this is a problem for me now. Alright, so I'm gonna press the switch. As you can see, the current there is 20 milliamp. 3 volt is out. No 5 volts. Alright, so I'm pressing the switch. I'm not getting 5 volts. Interesting. No 5 volts. 1.8 volts is there. Can't, because the power good from 3 volt and 5 volts is going to turn on 1.8 volts. VCC PRIM 1.8, and this is VCC in AUX 1.8 volts, right? So I'm not getting any voltage. So I will need to use oscilloscope now to check if I'm getting an over voltage or over current protection. I'm not sure. Only the oscilloscope can tell me that. Pressing the switch again. Alright, 3.3 volts is there. 5 volts is not there. I need 5 volts. And I already checked the resistance. I already checked the resistance on all the coils, and I got good reading. Five volts is 395. Alright, let me see if 19 volts is coming to the input of this PWM chip. Yes, 20 volts is coming in. Alright, so I'm going to get the oscilloscope and see what the output voltage is. Okay, so the oscilloscope is out. Alright, so here's the test point output. Alright, so I'm going to give power. Alright, there we go. We have white lights. I'm going to give power. Didn't catch anything. Alright, so let's go again. Alright, I press the switch. Alright, so there's no output. Alright, so the output is not there, so I'll have to check the working conditions of this chip. Alright, so I'm going to see if I can find a schematic. If not, I'll have to use a reference. Okay, so I have a picture here of the actual chip, which is the 5 volts chip, right? And its name is SY8270C, right? So as you can see, this is the pinout. The pinout starts from here, pin number 1, 2, 3, 4, 5, and so forth, right? So pin number 1, I also have a reference schematic, which is taken from the LAH323 because there's no schematic for the current board that I'm working on. So I'll have to use a reference schematic, right, which uses the same architecture but different generation of CPU. Alright, so as you can see, it is SY8207, sorry, SY8270CTMC, which is a QFN package, right? So pin number 1 and pin number 2. So pin number 1 is in, right? Pin number 1 is in. Pin number 2, we have LX, which is the phase output, right? This is the output voltage phase, right? And pin number 2, as you can see, LX, right? Pin number 3, we have ground, right? So pin number 3, it's ground here. And pin number 4, I have power good, right? And pin number 4, power good, right? So pin number 5, which is the enable 2, which is for the enable PWM output, right? And enable pin number 5. Right, so pin number 5, enable 2, and pin number 6 is enable 1. See, pin number 6, enable 1, which is enable 3.3 volts PWM. Right, pin number 7 we have FF, which is a feedback, right? Feedback, right? So see 5 volts feedback, 5 volts feedback. So pin number 7 FF, right? Pin number 7 FF. All right, pin number 8 we have output, which is detecting the output voltage to adjust the output voltage, right? So pin number 8, which is out, and pin number 8, as you can see, is out. All right, pin number 9 we have LDO, which is LDO 5 volts. All right, so after it's get the input, then it will output 5 volts. All right, LDO, which is taking roughly 150 to 300 milliamp. Right, so pin number 9 is LDO. Alright, so pin number 9 LDO, pin number 10 VCC, which is outputting 5 volts, which is for the internal buck conversion. Alright, so pin number 10 VCC. Alright, so pin number 10 VCC. Pin number 11, which is ground. Alright, pin number 11 ground. Alright, pin number 12 also phase output. Alright, pin number 12 and pin number 2 are in line, and pin number 13, which is boost. Alright, so this is the exact chip that I want. So this is the reference schematic that I'm going to use. Right, so I'm going to head over to the microscope. Alright, so this is the chip PL305. PL305. Alright, so I'm going to check the input voltage. Alright, so pin number 1, as you said, which is input, I get. Is that correct? Hold on, my charger is not plugged in properly. Alright, pin number 1, which is here, and I get 20 volts. Oops, my multimeter is not on screen. Alright, so pin number 1, 20 volts. Right, the next pin we need, right, we need the LDO. Right, so LDO, as I said before, is pin number 9. Right, so we count in this way, so that's 1 2 3 4, right, 1 2 3 4 5 6 7 8 9. Right, it's pin number 9. Alright, I count again. So that's 1 2 3 4 5 6 7 8 9. Sorry, that's 1. And I'm not getting 5 volt LDO output. No output here. There's no 5 volt LDO. Right, so after it get the 20 volts here, then it will immediately release LDO because there's no enable for it. Right, so let's go back. Let me go back to the schematic, because I know there is no enable for the right, so as you can see, we have input here. Right, so once 20 volts comes in, right, the only two enables I see, which is these two, which is going to turn on one for, oh yes, I was incorrect. We have two enables. So one is for LDO and one is for 5 volts. I was wrong. I was definitely wrong. So 5 volts, 20 volts come in, right? And then once 20 volts is in, let me zoom out a little bit. So to enable LDO is going to come to pin number 5, right? So this is normally coming from our EC, right? So I need 20 volts or 19 volts, and I need pin number 5 enable. After the switch is pressed, then it will send 5 volt enable 3.3 volts to enable the turn on LX underscore 5. Yeah, so this voltage is normally coming from the EC. Alright, so regardless of the boards, the architecture is the same, right? So I will do a quick search here. Alright, so as you can see, oh, so it's coming from 19 volts, so it's not the EC, so the same 19 volts coming through a voltage divider here. As you can see, I have the upper or the pull-up resistor, which is 499, and the pull-down resistor is 150k, right? So this will produce the output voltage, right? So let me see if I can do a quick calculation here. All right, so my input voltage is, so my resistor, that the pull-up resistor is 499, right, plus the pull-down resistor, which is 150, right, that will equal to 649 kilo ohm, right? So 19 volts, right, divided by 649 is going to equal to 0.029. I'm going to multiply by the 150 kilo ohm, and that should give me my output voltage, which is 4.4, right? Just round this off to 4.4 volts, right? So I'm going to check at pin number 5 to see if I'm getting 4.4 volts. Okay, so yeah, so I'm going to check out pin number 5. Pin number 1. 1, 2, 3, 4, 5. Oops, my meter is off. Yes, I get 4.7 volts. That's in the threshold, right? But I'm not getting the LDO. So I'm going to check if there's a short. Pin number 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 564. So could it be that this chip is bad? So I'm getting the supply, I'm getting the enable turn on, but it's not outputting the LDO voltage. So that is why when I press the switch, I only get 3.3 volts, and not 5 volts. So the 3.3 volts and 5 volts PWMIC will combine together to produce 3 volts pull up and produce power OK, or this SPOK. So SPOK, this on pin number 4, right? This is going to turn on the 1.8 volts. VCC PRIM 1.8, so it's VCC PRIM, right, underscore 1.8, yeah? So 1.8 volts, which is this one, right? So this is the CPU, right? Remember, I'm dealing with a 12th generation, right? So this is, let me see if it tells me which generation. Whiskey Lake, right? So this is a 8th generation CPU, right? So Whiskey Lake, which is U, which stands for ultra low power, right? The U stands for ultra low power, right? It's a low powered CPU, or ULT, which stands for ultra low power, and you have LP, which is for low power, right? So 1.8 volts VCC PRIM 1.8 is going to produce by this power OK, which is produced by 3 volts and 5 volts. So once the 3 volts and 5 volts power supply is stable and OK, then it will produce VCC PRIM, which is this 1.8 volts, right? So there's not, as I said before, there's not much of a difference with the schematic. It's just the CPU generation that makes the difference, right? So I'm going to replace this chip and see what happens. So I'm gonna see if I can find one. Okay, so I found a board that I have a donor. As you can see, I removed several chips from the board, CPU and so forth, but this is the chip that I need. Alright, so I'm going to remove it. Alright, so I'm gonna plug in charger. Alright, so alright, so I'm gonna measure. Now I have 5 volts. Alright, so as you can see, I have 5 volts LDO. Alright, so 5 volts LDO is there. Right, and the PWM output will only appear after the switch. Alright, so I'm gonna press the switch. There we go, port is fixed. Alright, so as you can see there, understanding the working conditions and timing, then it will be very easy for you to troubleshoot, right, and diagnose different faults. Okay, yeah. All right, so I'm going to do a complete check. So this is the tiny. All right, this is a Synergy chip from Synergy SY8207, right, 8270 C series, C, which means that it's 5 volts, right, and that was the fault, right. So I'm going to do a complete check now. All right, so I'm going to get the heatsink. No, I don't need the heatsink because I need to check some core supply rails. All right, so all right, so this is my trusty heatsink there, as you can see. All right, so I'm going to give power. All right, so I press the switch and I switch on. As you can see, the current now is, oops, alright, so my DC power supply wasn't on camera. Alright, so as you can see now, I'm going to press the switch. Alright, I have 2 lights now. And it's powered off. Alright, so 5 volts output. Excellent. 1.8 volts. Excellent. Another 1.8 volts. Perfect. Alright, and these are the core. 0.8, 0.8. RAM supply 1.2 volts. Excellent. VPP 2.5 volts. Excellent. As you can see, all the rails are generated. Right, so that's what I want. Right, so so the 5 volts LDO wasn't generated to produce VCC, right? So the 5 volts LDO, let me go back to the reference schematic. So the 5 volts LDO, which is going to produce VCC, let me go back to my previous section. Right, so here, right, so this was coming, but I was not any LDO 3 volt 5 volt was coming, but I wasn't getting any voltage at pin number 9. Sorry, this one. Right, so pin number 9 wasn't giving me any voltage. Right, so this 5 volt LDO is used as a reference. Right, so it's going back into the chip. Right, it's going back into this chip. Right, so the 5 volt LDO is going back into the chip. Right. Right, and another part is going out as well. Right, so this LDO is going to come out here as VCC, right? It's going to turn on a buck conversion inside of this chip, right, to power this chip, right, so it can output 5 volts, right, PWM, right, so this is PWM, right, And PWM, which you all know, stands for pulse width modulation, and that is controlled by a duty cycle, which is going to have internal MOSFETs, right, which is switching at a high speed, right? So these MOSFETs switch at a high speed, and which is controlled by this PWM chip, which is the buck conversion inside of this chip. So this is used to power the 5-volt LDO is going to power the buck conversion, because if and it doesn't need 19 volts. The 19 volts is for the upper MOSFETs that's inside, right, and the lower MOSFET. That's why we have two ground. You notice we have a ground which is for the lower MOSFET, right, and we have another ground here for the chip itself, which is earth ground, right? So these two MOSFETs are going to switch, right, which is controlled by this buck conversion, and it's going to output LX 5 volts, right, and it's also connected to here to go to the coil, right, to output, so it can have a smooth, stable DC output coming through this coil, right, as you can see. And we have filtration, which is for filter capacitors here, right, which is going to smooth out the voltage and to keep it at a constant, stable 5 volts, right? So this is the chip. All the working conditions are operated inside, so there's no MOSFETs on the outside, right? So this is an integrated PWM drive chip. It's also a typical PWM chip. As you can see, we have a boost circuit here, right? So the boost, right, this capacitor is very important. If you remove this capacitor, this chip will explode, and it will burn out the upper MOSFET, and that is why you always have a deep burn on this V-in pin here, right? So the 19 volts is coming to the upper MOSFET, which is burnt, and a large explosion will occur if I remove this capacitor, right? So this capacitor is basically a self-boost capacitor. What is it called? It's called a self-boost, right? Capacitor. It's very difficult to write with the mouse, right? So the self-boost capacitor is used to charge, right? So how it works: when the upper MOSFET inside of this chip is conducted, right? This is the lower MOSFET. So it takes 19 volts, which is controlled by the buck conversion inside, right? So this buck conversion, there's an integrated diode inside, right? There's a diode which is connected to this part of the diode, and this part, the anode, and the cathode is connected back to the what? This buck conversion. And another part is controlled by the gate. The gate is here, right, and that is controlled by this buck conversion gate. So this is going to do a high speed switching. So when this switch on takes the 19 volts, it's going to take the 19 volts and add it here. Sorry, not there. It's going to take the 19 volts and add it here. Sorry, 19 volts is coming to the input inductor, right? This is the front end of the inductor. So the 19 volts is going to come here, right? Each time it switch, 19 volts is hitting here at every time. High speed, very fast. You only can capture this on an oscilloscope, right? So the 19 volts is going back to charge this capacitor, and this has a boost of 5 volts. So 19 plus 5 is going to give us what? 24 volts, right? So there's 24 volts coming to the gate of this MOSFET that is inside, right? 24 volts is coming to the gate, right? Let me draw back the circuit again. Upper, lower MOSFET, buck conversion, yeah, right? Right, so this is the upper MOSFET drain pin, and it is connected to the 19 volts here, right? And that 19 volts, right, is going to come and conduct internally and goes to the coil that I've just showed you at the front end of the coil, right? So at the same time, this capacitor here. Oh, I have a better marker. Is this the one? Yes. Right, so this capacitor will charge, right? So 19 plus 5 here, 5 volts on this side, 19 volts on this side, charge the capacitor, and it will send 24 volts to the upper MOSFET gate, right? So that 24 volts is going to drive this MOSFET, and it will do a full conduction, and then it will output the corresponding voltage, which is controlled by this chip itself, which is a PWM chip, right? So here you have a lot of pulses here, right? So this is the pulses, right? So each of these is when the lower MOSFET is activating. So it will charge and discharge, charge, discharge, and so forth and so forth. So it's like a battery, and then it will provide a smooth output, and it will constantly provide, and it will store the energy. This is an energy storing component, and release it slowly as electrical charge with the help of the filter capacitors to smooth out the voltage and provide us with 5 volts always, right? Once that 5 volts is always is okay, then the out pin, as you can see, out, there's an out, right? This out pin, as you can see, is connected to the feedback, is going to detect the 5 volts, right? And then it will send the power good signal, open the latch. There's a latch that is going to be open, and it will become SPOK 5 volts. After passing through this resistor PR310, which is a 0 ohm resistor, it becomes power OK, right? The OK is going to turn on the 1.8 volts VCC PRIM, right? Right, so VCC PRIM, right, is pulled up. That's not connected. This is a for RSM reset. Right, it goes to some of the places. This is where I'm coming from. Oh, this is 3 volt. So once 3 volt is generated, it will combine, and this is where I'm coming from. Right, all of these are SPOK. I'm not missing anything, right? Right, SPOK. SPOK. That's not connected. That's connected to RSM reset. Alright, so that SPOK, which is this chip, after producing 3 volt and 5 volt output, then the production of 1.8 volts. Oh, it is controlled by a different series. So this one is slightly different. So PCH power enable is going to release from the EC once the EC gets RSM reset, right? So this board is a slightly different board in terms of this part, right? So PCH power enable is normally coming from the embedded controller. Search. All right. See? Right, this is the embedded controller, as you can see, and it is a KB9022QD. The D indicates that it's programmable. Right, it's as an embedded firmware. Right, so once this releases PCH power enable, right, so it gets SPOK. So SPOK is used for once it gets RSM reset, then it will turn on PCH power enable here. But this is a slightly different one, so I don't want to get you confused, so I won't go further because this is a different board. Alright, so I'm going to assemble the unit and be back. Okay, so the unit is now assembled. Right, so I will now connect the power. All right. Have a slight little Alright, so I'm pressing the switch. Switch over to camera 1. Alright, so 1 amp, 900 milliamp. Alright, so it'll have to do some series of, there we go. So the current is now initializing. As you can see, the active management technology on the ME engine firmware. There we go. So I have display there. Let me switch over to the other camera. Alright, so that's a done job there. Is it off? Oh, there we go. We have HP. And it's loading up. Alright, so there we have it. It's a done job. That sounds so nice. Yes. Alright, so I started my day well. Alright, so I hope you enjoyed. I hope you learned something. And you can also like and subscribe. Right, and tell me what you think about the repair. Alright, so that's it for now. So in the next video, I'll definitely repair something for you again. Alright, bye.